Hey everyone, today we are diving into what I think is a genuine superpower for anyone who manages projects. It's called the critical path method, and it's this brilliant way to find the absolute backbone of your project's timeline. So let's get right into it.
You ever wonder about this? It's a huge question, and the answer isn't just about working harder. It's about seeing the project's hidden structure. And that's exactly what the critical path method was built for, to solve this exact problem, by showing you the one sequence of tasks that truly dictates your finish date. You know, you can think of any project as a giant puzzle. It's got all these pieces, right? Sometimes dozens, sometimes hundreds, and they all have to fit together in a very specific order. Well, CPM is like getting the picture on the front of the box, so you can finally see how everything is supposed to connect.
And at the heart of this puzzle is this web of dependencies. You know how it is. Task C can't even start until task A is finished. And task F, well, it needs both B and D to be complete. For anything more complicated than a simple to-do list, trying to juggle all of that in your head is, frankly, a recipe for disaster. You need a system.
Okay, and this brings us to the really interesting, kind of counterintuitive idea at the heart of the critical path method. To find the fastest way to finish your project, you first have to find the longest path through it. I know, it sounds totally weird, right? But stick with me. This quote says it all. See, unlike finding the shortest way to the office, where you can just ignore all the longer routes, in a project, you have to do everything. Every single task has to get done. So the absolute minimum time your project will take is dictated by its longest unbroken chain of tasks. Let me give you a really simple analogy. Imagine you and 4 friends are out at a restaurant. You all want to go see a movie afterwards. Now, some of you eat really fast, and some of you, well, you take your time. The project of dinner isn't over until that last person has put down their fork. So, no matter how early everyone else finishes, your group cannot leave until the slowest eater is done. Their eating time is the longest path. That person's timeline controls the entire project's finish time, and that, right there, is the critical path in a nutshell. And this little table just nails the difference in logic. For a commute, your goal is to find the single shortest path and take it. For a project, your goal is to identify the longest path because you know all the other, shorter paths of tasks will finish while you're still working on that main one. So, with that in mind, here's the formal definition. The critical path is that specific chain of dependent tasks that, when you add up all their times, takes longer than any other chain. And because it's the longest, it sets the absolute shortest time your entire project can be completed in.
All right, so we get the what and the why, but how do we actually find this thing in a real project with dozens of tasks? Well, luckily there's a wonderfully logical, step-by-step method for doing just that.
It all starts with making a visual map, and we call this a network diagram. We draw a box for each task and then use arrows to show how they all depend on each other. Inside each of these boxes, we're going to calculate 4 really important dates: the early start, the early finish, the late start, and the late finish. Basically, the absolute earliest a task can happen and the absolute latest it can happen without messing everything up. The whole process is really just 4 steps. First, you draw your map. Second, you do what's called a forward pass, where you start at day 1 and work your way forward, calculating the earliest possible start and finish times for every task. Third, you do a backward pass. You start from the project's finish line and work your way backward to find the latest possible times. And then, finally, you look for the path where the earliest and latest times are exactly the same. That's it. That's your critical path.
Now, what's so cool about this is that the calculation doesn't just give you the critical path. It also reveals a project manager's secret weapon, something called float. This is where you find all the hidden flexibility in your schedule.
Float, sometimes it's called slack, is pure gold. It's your wiggle room. It's the amount of time that a task not on the critical path can be delayed before it even begins to threaten the project's final deadline. It is your buffer. It's your safety net. And calculating it is incredibly simple. Once you've done those forward and backward passes, you just subtract a task's early start time from its late start time. The difference? That's your float. So if a task can start as early as day 5, but as late as day 8 without causing any problems, you've got 3 days of float to play with.
And this brings us to the most important rule of all. By definition, every single task on the critical path has 0 float. Zilch. Nada. Their earliest start time is the exact same as their latest start time. There is no wiggle room. And that means if a critical task is delayed by even 1 day, the entire project finish date gets pushed back by 1 day. Period.
So let's bring it all home.
Understanding this path isn't just some academic exercise. It is the most practical tool you can have for steering a project to success because it tells you exactly where you need to focus all of your attention.
So if you remember anything, remember these 5 golden rules. 1. A delay on the critical path always delays the project. 2. If you want to finish early, you must speed up tasks on the critical path. Speeding up anything else is a waste of effort. 3. Yes, a project can have more than one critical path, which is risky. Now you have multiple high-wire acts to manage. 4. The path isn't set in stone. It can actually change as your project goes on. And 5. Always watch the near critical path, the next longest one, because just a small delay there can make it the new star of the show.
So now you know the logic. The next time you're staring down a complex deadline, don't just make a to-do list. Map the dependencies, find that longest path of zero-float tasks, and you'll know exactly where to focus to bring that project home on time.